back, Math 8. Today we are going to go through a lot of stuff actually compared to the last lesson. We are going to go through number 1, identification, number 2, setting up the pattern from the table, and number 3, we're going to go through something that I like to call slope. And when it comes to identifying and setting up the pattern, we can write down in a sentence, like word sentence, describing words, and at the same time we are going to go through how we can use symbols to figure out that. Without further ado, since we have lots of things to do, let's go through our first example. This is available on your math workbooklet, page 15. The pattern in the table of value represent a linear equation, or linear relation, sorry. And we need to do 4 sub-questions. A, graph the order. B, what is the difference in value for consecutive A value and consecutive B value? B actually help us determine something that I like to call slope. So have that in your mind. C, describe in words the relationship between A and B. And at the same time, I'm going to add something in here. Not only in words, but also using symbols. Using numbers and symbols. And variables. There you go. And D, what is an expression for B in terms of A? Which is very similar to C over here. Except the second part. So we're going to go through various stuff. One thing that you need to understand is, ladies and gentlemen, although it's not always true, but most of the time, one on the left represent independent variable. Which is what we call input. One on the right side represent dependent variable. Which is output. It is good thing to understand that independent variable kind of resemble as X. Dependent variable kind of resemble as Y. So without further ado, if you look at the pattern, every values on X, or in this case A, is positive, other than the first one. Same thing happened when you look at the dependent variable output. Everything is positive. So that means you don't have to draw quadrant 2, 3, and 4. Only quadrant that you need to draw is basically quadrant 1. The one that play a huge role for each of them. It is good idea to identify independent variable, which is X variable, on the horizontal number line, which is x-axis. And second one, responding variable output, B. As you may notice, I'm changing the orientation on purpose, and that's what you should actually make it into habit, especially when you go to science. The first coordinate is 0 and 0. So I have that. And at the same time, it's a good idea to identify what's my maximum numbers, like Y variable. Can you see that the maximum value is 12 over here? So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. I put 15 on purpose so that we can easily put 12 without reaching to the maximum height over here. When it comes to X, you have 1, 2, 3, 4. So 1, 2, 3, 4, 5. Something like that so that you have enough of space. First coordinate was 0 and 0, so that was origin. 1 and 3. 2 and 6. 3 and 9. 4 and 12. We have these coordinate, and I know it is just coordinate that we have. It is good idea to have a line connected just in order to see the pattern for answering the next question, which is a slope. This is what we have for answer of A. We graph the order pair using a table. Now, B, although the direction can be confusing for some of you when you read like difference in value of consecutive A for consecutive B. It's just a fancy way of referring. Do you have any pattern going on when you look at just independent variables and the values in series and under the column B? If I look at my column A, 0 to 1, 1 to 2, 2 to 3, 3 to 4, as you may notice, everything is increased by 1. So, I like to say, when it comes to A values, they all increase by 1. Similar as yesterday, except yesterday we have more fill-in-the-blank kind of fashion when we answer this pattern, but now we have no guideline. It's our job to figure out. When it comes to B values, first of all, we need to think, is that increasing or decreasing? 0, 3, 6, 9, 12, as you may notice, it's increasing number. So there must be some kind of addition going on. And it is our job to figure out. 0 to 3, you are adding things by 3 to get there. But does that pattern repeat for the second and third? Yes, we do. 3 to 6, 6 to 9, 9 to 12. So as you may notice, everything is increased by 3. Now, although the question asks you to figure out these patterns, now we're elaborating one more step, something that is known as slope. And I'm going to use both my answer in B and answer in A. Slope, ladies and gentlemen, is basically, people teach this concept in two ways in junior high and a little bit more advanced way in high school, but I'm going to tell you the most common one that people use. People use it as rise over run. This is how we figure out the slope. But some people talk about, what do you mean rise over run? And I like this method, and at the same time I dislike this method because of one reason. When people mention about rise, that's vertical change. What I mean by that is, are you going up by something or are you going down by something? In the word rise, in English, that means everything is going up. This is the reason why I don't like using it, because in slope, you can actually have a drop of the graph. Decreasing is also possible. So just because you use the word rise over run, it's not always positive, just for the heads up. If there's a vertically going increasing situation happen, then it's positive. If it's going up to down, then it's negative. When it comes to run, it's a horizontal change. That means, am I going left to right, or right to left? When it comes to this situation, if you go left to right is positive, right to left is negative. In junior high, if I'm telling you, like 80% of situation, you always go left to right, like the one that you see in question part A. So, how can we find the slope? Well, your answer in B actually telling you vertically. So rise part, are we increasing by 3 or decreasing by 3? We are increasing by 3, so it's positive 3 on the top. If you look at horizontal change, it increases by 1, so that means it's positive 1. So slope, ladies and gentlemen, is actually 3 over 1. But you need to remember, do we actually put 3 over 1 in normal situation? I like to say no. If you have denominator 1, you generally put just slope is equal to 3. This is one of the main part of today's lesson. First thing first, you have a table and you identify the pattern for each dependent variable and independent variable. But once you have that, we can mathematically show the relationship of this increase and decrease in horizontal and vertical situation. That's what we call in slope. And slope value can be expressed in number. So slope is equal to 3, telling me that, okay, that means my vertical part, it increased by 3. My denominator, which is horizontal part, it increased by 1. Something like that. And we're going to do more example. If you look at the graph situation, this slope also works for each of horizontal and vertical. From first and second, can you see that you need to move left to right by 1? Same thing happen for each of the dot. So we know that horizontally, you're adding it by 1. Vertically, if you look at it, you also go from down to up. So as you may notice, the stair is going up. And if you count the grid, you know that it's increased by 3. So slope can be actually also found from the graph too. Let's look at C. Describe C and D. I'm going to do it together actually. Describe in word the relationship that is happening between A and B. Now we are talking about the direct relationship, what's happening from left to right. Always read the question carefully. Slope does not necessarily tell you what's happening on variables like input to output, but it is our job to figure out. 0 to 0, when it comes to your operation, bad math, adding, subtracting, multiplying, and dividing, it's a little bit tough to find out because 0 becomes 0. Then go to the second one. 1 turning into 3. That means you have two possibilities. Is that adding situation or is it multiplying situation? If you think about adding situation, 1 plus 2 is 3. So plus 2 should be the pattern. But does that work for the third one? 2 plus 2 is unfortunately not 6. Remember, relationship, whatever the pattern that you find from relationship, it has to be consistent for the next sequences. So, addition doesn't work sadly. What about multiplication? 1 times something should make the answer 3. 1 times 3. That means, does 2 times 3, that pattern, leads to the output 6? Yes, we do. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So, from A to B, we identify that when we try to describe the value of B is determined by A multiplied by 3. In Word, this is a pattern. But as you may notice, the word explanation, it can be quite tedious and long. You don't want to write down every time like that. Then what's my best way of showing it? Like the word, it says the value of B, that's a fancy way of saying B equal to, is determined by A multiplied by 3. But we don't put our relationship in this way. Always number first and then letter later. So long story short, you can put it this way. B is equal to 3A or B is equal to 3A. Doesn't matter whether you use small or large capitalized letter to identify the variable in grade 8. But if I'm spilling the bean a little bit, independent variable, we generally use lowercase. So this is how you answer the question D. What is an expression B in terms of A? It's 3 times A value that makes B value coming out. Let's do more. Page 16. This time I'm gonna speed things up. We have 2 tables. We need to identify the pattern in the value for the first variable in each table. And second, identify consecutive values. Third, graph each set of the ordered pair. And D, how does your answer in C compare to the D? So, we have a lot of things going on, as you may notice. But we need to identify that it is important to go through some of those pair that you see in table 1 and table 2, and we're comparing it. So let's get this started. Let's look at our first question. It is asking about patterning the value of first variable in each table, and B is asking consecutive values. So I'm going to do A and B together, okay? first thing first. We need to understand that when it comes to first variable, that's the first column in this case. What is happening from 2 to 3, 4 to 7, 6 to 11, 8 to 15, and what is happening for the other one too. So, we need to find the pattern in here. Now, the thing is, if you look at the first one, 2 to 3, easy way that you can think of is, well, it's added by 1. 4 to 7, it's added by 3. So as soon as you see this, addition sadly doesn't work because 2 plus 1, that pattern, 4 plus 3 to become 7, these two does not agree. So addition is out. What about multiplication? Sadly, 2 times something doesn't go to 3. 4 times something doesn't go to 7. But here's something that you can think of. What if you do multiply by 2? Is there any close number that you can get? So what I mean by that is 2 times 2 is 4, which is close to 3. 4 times 2 is 8, which is close to 7. Some people may already find the pattern at this point. 6 times 2 is 12, very close to 11. 8 times 2 is 16, that is also close to 15. So, if you look at that situation, I wonder whether you find the pattern or not. 3, 7, 11, and 15, those are all numbers that if you multiply everything by 2, then if you minus 1 from it, then you will get these y value. So, the pattern, ladies and gentlemen, for the first table, table 1. In order to explain that pattern, if I write down the sentence first, y values, or the y value, let's go individual. Y value can be found if we multiply x by 3 and subtract 1. That is my pattern of the table number 1. If I write this down in a mathematical algebraic expression, y is equal to multiply x by 3, so 3x. Always remember, number comes first, letter comes later. And subtract by 1, 3x minus 1. That is how you can show the pattern. Like I said, today's lesson is a little heavy because it does involve multiple thinking. What about table 2? Now let's think. 1 to 1. There's nothing that happening here, right? 2, like either addition, then you're adding 0, which is nothing. If there's something, it's multiplied by 1 because 1 times 1 is 1. What about the second? 2 times 2 become 4. But sadly, 3 times 2 doesn't get to 6. It actually becomes 7. 4 times something, well, 4 times 2 become 8. So the thing is, 2 to 4, 4 to 8, this plays a huge role. But as you may notice, it doesn't agree with 1 to 1, 3 to 7. What about, then in that case, like what you see over here, what about 2 type of operation? Well, what about 1 times 2 minus 1? Then it agree with 1. But if you look at 3, 3 times 2 minus 1 doesn't agree with 7. In this situation, the one thing that you can do, ladies and gentlemen, is, and this is where B part plays a huge role, we can compare consecutive value. What I mean by that is, if you look at just x that go from previous one to next one, and so as y, we can actually find if this is a linear relationship or not. 2 to 4, do you see that it's added by 2? 4 to 6, added by 2. 6 to 8, added by 2. Can you see that? Constant adding and subtracting if there is. If these guys agree, then it's linear relationship. 3 to 7, can you see that you're added by 4? 7 to 11, added by 4. 11 to 15, added by 4. This pattern also works. But I want you to look at these guys. 1 to 4, that's added by 3, right? 4 to 7, that's also added by 3. But look at the next one. 7 to 8, that's added by 1. As soon as you see that, it does not agree to each other. So, table 2, you can see and then write that in this way. No linear pattern exists because we don't see any common patterns in n, that's what you see over here, n consecutive values. If that happened, ladies and gentlemen, we cannot express it in algebraic expression. That is a pattern in A and B, which means we cannot find the slope too. Because the thing is, slope is linear. We don't have a linear relationship, so there is no slope. However, do we have a slope in the table 1? Yes, we do. The slope of table 1, or I like to say slope big 1. Can you see that my y value, vertical value, it increases by 4, right? So if I look at rise over run, vertical increases positive 4, but when you look at horizontal, it increases by 2, which means it's 4 over 2, which you know that we can simplify, divided by 2. Then it's 2 over 1, then it's 2. Slope value is positive 2. But when it comes to the next one, we can. And the way that we can find it is, if we graph everything, it will be more evident. Let's do the graphing. Table 1 and table 2. Two, 1, 2, 3, 4, 6, 8. As you may notice, sorry, it's a little ugly graph over here, but we have the values of the first table, x, y, and then we can actually connect it into vertical line to show that linear increase. But when it comes to table number 2, this one I gotta be careful, and I have to be as precise as I can. 1, 2, 3, 4. There's 10 grid over here. The first value is 1 to 1. Second value is 2 to 4. Third value is 3 to 4, 5, 6, 7. Fourth value is 4 and 8 over here. If you look at this graph, can you see that it's actually going like curve instead of linear? Because from 1 to 2, you increase by 1. 2 to 3, increase by 1. 3 to 4, increase by 1. We know that pattern. But if you look at vertically, 1 to 4, we have added by 3. 4 to 7, at least this part, we can agree. But 7 to 8, oops. Sorry, I put the wrong graph over here. I'm going to fix this part a little bit. Just hold it a minute. 4 to 8. That's just one increase. As you may notice, from here to there, 7 to 8, you have curve that going up and then suddenly the curve that going down like that. These two sections are curved graph. It's not linear graph. So that's why finding the pattern and have that consistent pattern, unlike the previous one, was impossible. Even though, sorry about my ugly drawing over here, if you actually draw properly, it's gonna go linear graph. Because example 2 doesn't have any curve, and then this was value of m, value of n, they do not have any slope because it's curved, and at the same time we cannot produce any type of expression. I think what I'm going to do is we're gonna have a little pause button because the video is already getting into 25 to 26. Your homework, ladies and gentlemen, yes, doing question 5, 7, 10, 11 on page 348 to 351. That is today's lesson.